Hello, my name is Greg Leak, and I'm a Director of Technical Product Management on the Microsoft SQL Server team. And today I'm going to demonstrate our cloud-based relational database service, which is called Windows Azure SQL Database, and it's based on SQL Server. Okay, so let's begin the demonstration. The first thing I'm going to do with Windows Azure SQL Database is create a new virtual database server in the cloud. To do that, I'm going to start in the Windows Azure Management Console. And that is an HTML5 management console, so you can actually manage Windows Azure and Windows Azure SQL databases from any device that renders HTML5, whether that's a cell phone or a tablet or a PC, it doesn't matter. So here's the management console, and you'll notice that we have a tab here for SQL databases. These are my Windows Azure SQL databases. The great thing about Windows Azure SQL Database is it's completely compatible with Microsoft SQL Server. So it's based on SQL Server technologies. If you know how to develop for SQL Server, you know how to develop for Windows Azure SQL Database. But one of the more powerful things about Windows Azure SQL Database is that it's a managed service. So you don't have to think about provisioning storage or managing transaction logs or any of those low-level details. It's really what we call platform as a service. So it's really easy to create and manage new databases in the cloud. And the other really important point with Windows Azure SQL Database is when you create a database, it automatically builds in high availability. So that means when you create a virtual database server, any database you put on that server actually gets a primary database and two online hot replicas, such that you don't experience any application downtime, even as we, Microsoft, patch and manage the software behind the scenes. So in fact, that HA technology, I'm going to show you how easy it is to create a new database with these three replicas. I'm just going to say create a new database, and I'm going to choose a size and a name for the database. I'll choose test database as my initial database. And I'm going to choose a server, but I don't really have a server, so I'm going to create a new virtual server. And again, this virtual server is going to point to all three replicas so that there's failover built in. In fact, we have a 99.9% uptime SLA with every Windows Azure SQL database. I'll go to the next tab. I'm going to give myself some admin credentials. This is the equivalent of the SA login to the master database. So I've got to type in what credentials I want to use as the master credentials for the admin and make sure I get that right. And I'm going to choose a location. You can choose from one of 8 worldwide Windows Azure data centers. Let's put this in East Asia. And so I'll choose the East Asia Data Center and click the OK button. You can see down here in my status bar that it's creating a test database on a new server in the Windows Azure East Asia Data Center. It's quick and it's done. You can see that just took a matter of seconds, which is pretty amazing if you think about how long it typically takes to set up a high availability relational database environment in an on-premise environment. Here I didn't have to buy any hardware. I didn't have to buy any software. I don't even need a license to SQL Server. You're just billed based on an hourly rate. So you don't need hardware. You don't need software. You literally just get started with a Windows Azure subscription and the management portal. So now that I've created my test database and my server, I can go to the Servers tab and see that my server has been given a logical name. I'm going to go ahead and click on that server. I'm going to do a quick configuration here. Windows Azure SQL Database has a built-in firewall. So if I want client tools like SQL Server Management Studio or Visual Studio to access it, I need to allow different IP addresses as client IP addresses to access that database. So it's very secure by default. But I'm going to go ahead and give this a rule of all. And I'm just going to go ahead and add an IP address range. And we'll make this just a full range here. And we'll save that rule off. And now I will be able to access this database from different client PCs running all the different SQL Server tools. Now the next thing I'm going to do is I'm going to transition from the management portal right to Visual Studio 2013. And I'm going to show off some powerful features of Visual Studio 2013 called the SQL Server Data Tools. So here is Visual Studio 2013. And the first thing that you'll notice is integrated into Visual Studio 2013 is a SQL Server Object Explorer. This is part of the SQL Server Data Tools. And I can go up and connect to this new server that I created. So if I go over and I see that the server, if I go to my dashboard, I can see my server name. is this logical name. This is just a connection string. So I'm going to copy that connection string out into Visual Studio and create a new connection to this Windows Azure SQL database. I'll paste that server name in. I'll type in my management credentials. And I'll say, remember my password, and connect up to this Windows Azure SQL database directly from within Visual Studio 2013. I can now open up this server, and I can see the databases that are in it. And remember, we just created a blank database called test database. So that's the only database in it. And there's no tables or anything yet defined in this test database. Instead of creating a new test database, I thought I would do something more exciting, which is migrate an on-premise database into Windows Azure SQL database using Visual Studio 2013. So what I'm going to do is I'm going to go ahead and establish a connection to an on-premise database just by clicking the Add Connection button. And this time I'm going to connect up to my local machine that's running full-on SQL Server 2014. And I'm going to connect up. And you'll see I have a new connection now to an on-premise database. So I can manage both cloud-based databases in Visual Studio 2013 as well as on-premise databases. And here I've got an existing database called the Stock Trader Account Database. I can open it up and see that it's got some tables defined. For any table, I can open up the table and get designers that show me the actual schema for that table. I can change the schema if I want, either via T-SQL or the query designer. But what I'm going to do is actually migrate this to a Visual Studio database project. So I'm just going to right-click on that database. I'm going to say Create New Project. And I'm going to name this project Azure Stock Trader DB because I'm migrating it from on-prem to the cloud with Windows Azure. And I'm going to go ahead and import reference logins. Now, one cool thing here is I can add this directly to source code control inside Visual Studio 2013, in which case all my database objects are now going to be managed for team-based development in a very secure and source code control locked down fashion. So I'm going to go ahead and create a new solution and start this process. I'm going to get a wizard that's now going to create a new solution that I can use for offline development and schema changes for this database, including my migration from on-prem to the cloud. So I'll just click Finish, and here are all of my objects in that database, my stored procedures, my tables, and my views. Okay, at this point, let's go ahead and pin this guy so we can continue to see our Server Explorer. At this point, I could open up, let's open up a view. And then here's a view, and I get a T-SQL editing. And I can go ahead and do some powerful things. Everything that you have from a C# development perspective, you now have in the T-SQL language. So if I want to say, okay, this is a view selecting from the table orders, I can right-click and say, let's go to the definition of the orders table. And immediately it'll pull up the definition of that orders table. If I wanted to see everywhere that the open date column is used within this database schema, I can right-click and say, find all references. And here's all the references to that particular column definition, just like you can do in C# development, but now brought to the T-SQL language. So let's go ahead and close out of this table definition, and let's go ahead and find out where this view is actually referenced. So I'm going to go ahead and find all the references to this view. And I can see that it's referenced in the create procedure, but it's also referenced here in a stored procedure. So I'm going to open up that stored procedure. And we can see here it's doing a select, the stored procedure is doing a select star from the view. Well, if you're a SQL database administrator or developer, you know that doing select stars is really kind of a bad practice. You really want to specify the actual individual columns when you do a select. So I can hover over that star, and you can see the level of IntelliSense that we've got built in here in Visual Studio. It shows me the actual columns when I hover over that star that are part of this view. But better yet, I can simply right-click and refactor and say expand those wildcards and apply that, and it'll change it to a proper SQL statement using the actual columns from the view. So there's one change I've made to this schema in my project. Let's go ahead now and close out of this and go into the table orders, and go into the designer. So I'm going to say View Designer. And what I'm going to do in the designer here is go ahead and add a new column. So let's scroll down here and add a new column, and I'll just call it New Column. and it recognizes all the SQL Server types, so I'll just go with ncar, and I'll go ahead and save this off. Okay, so that's saved. So I've now made 2 changes to my schema in my offline development project. Once you start making changes to schema, oftentimes you want to know if that schema differs from your source database or other databases you have deployed. And that's called schema drift. So what I'm going to do now is I'm going to compare the new schema to the original source schema using something really cool called schema compare. I'm going to right click on my project and I'm going to bring up the schema compare tool. Okay, I'm going to go ahead now and choose my target as my project. My source as my project as my source, and then I'm going to select the target database. The target database is going to be my original source database. That's the live database that I started with. So I'm going to choose that, and I'm just going to say OK. And now I'm going to choose compare. And what this is going to do is it's going to look at the entire schema for each of these databases and show me every individual difference that exists between these 2 schemas across every object in the database. So here you can see one of the things that I did is I added a new column, and it's highlighting that in yellow because it exists in my source database, but it doesn't exist in my original database. I can look at my stored procedure, and you can see again it exists in my source database because with all of the wildcards expanded, but in my original database, the live database, it still has the wildcard. If I wanted to update the target database and make these schemas exactly the same between the 2, I just click the update button and it will generate the update script. And once that script is generated, it will show me that I can go ahead and update the database. So at this point, my databases are updated and my schemas are equalized. Okay, the final thing that I want to do is I want to tie this all together by publishing this new database schema up to Windows Azure SQL Database in the cloud. So I'm going to go ahead and right-click on this project and bring up the project properties. And you'll notice here that we can target all sorts of different versions of SQL Server. In fact, with Visual Studio 2013, you'll also be able to soon target the new SQL Server 2014. But I'm going to change the target from 2012 to Windows Azure SQL Database. As soon as I change the target, I can do a build on this project to make sure that it will be a good schema that will deploy easily and smoothly to Windows Azure. So I'll rebuild this, and I'll go to my error list, and you can see that indeed I have 0 errors and 0 warnings. So at this point, I'm going to go ahead and just right-click on my project, and I'm going to say Publish. And where am I going to publish this to? I'm going to edit my target database connection, and it's going to be that server that I created in the beginning of the demonstration, and that's the server living in our Southeast Asia Windows Azure data center. And I'm going to type in my admin credentials, of course, so I can do this deployment. And I'm going to call it Azure Stock Trader DB. I'm going to say OK. And at this point, I can simply hit the Publish button, and here in the progress window, we can see the progress of the publish operation. And as this completes, what it's doing is moving this schema that originated with an on-premise database up into the Windows Azure cloud as a Windows Azure SQL database. So now this database is cloud ready, hosted in our data center with the high availability and the 3 replicas already built in. And as soon as this is done, we'll go ahead and take a look at it in the Server Explorer. Publish has completed. So I'll close out of this window and we'll go over and see if indeed the publish has completed. Remember, when I created the server, we created the test database. But if I go ahead and refresh now, we'll see that the new database is in fact here, the Azure Stock Trader database, which is now up in the Windows Azure cloud. I can look at the tables, the views, the stored procedures. Every object has been published, and it's now cloud ready. So that's the end of our demonstration. What you've seen is Windows Azure SQL Database in conjunction with the new Visual Studio 2013, being able to really create and manage powerful cloud-based relational databases.